improve the statistics so that the uncertainties that are that come out of the measurements are reduced. We maximize the energy reach because cosmic rays, there's less of them at higher energies, exponentially less. So you really need to stay up for a very long time so that you can measure the higher energy particles. And so by having larger statistics, being able to measure higher energies, we can use this to distinguish various models in the theory. So ice cream is not the only cosmic ray experiment in space. There's many others. Just a few examples are Pamela AMS, which is on the space station, Calette, Dampy. These are also direct cosmic ray experiments, but they measure at a little lower energy. However, their high energy has some overlap with our low energy, so the data that will come from ice cream will not only complement their measurements, but also add to them. There's also indirect measurements of cosmic rays. So you can measure cosmic rays after they interact in the atmosphere and they break up. So these experiments allow you to reach higher energies, but you can't tell the source as well. So our high energy reach overlaps with their low energy reach. So with all of these instruments and all these projects measuring cosmic rays, you can develop a fuller understanding of the cosmic rays in our galaxy. And I think that's it, yeah.
Okay. Thank you, Dr. Smith. And if you'll stay for just a moment for a couple more questions. Do we have any questions in the audience? If you do have a question, please raise your hand and wait for the microphone to get to you.
Hi, what do you need the information for? Is it just for understanding them and knowing more about it, or is it to measure how it affects human biology?
Well, cosmic ray physics for us is a fundamental science. So at this point, we've identified what they are, that they come from outer space, but we want to pinpoint the sources. Where do they come from? How do these objects in the universe create them? What kind of mechanisms can accelerate them to the energies that they have? The energy range that we measure them are higher than what we can make on Earth. So we want to understand these processes. And yeah, so it's a fundamental science. The energies are too high to affect the ones that we measure, biology and space science, but there's lower energy ones that do have these other effects.
Do we have any other questions in the room? Thank you, Dr. Smith.
Thank you.
Our next speaker is Michael Delp, Principal Investigator for the Rodent Research 9 investigation from Florida State University in Tallahassee.
Good afternoon. It's good to be here with you. So I'm part of the rodent research, and this is a program that's sponsored by NASA Space Biology. And really, it fundamentally looks at some of the biomedical problems that occur in humans with spaceflight. And we use rodents to try and better understand some of those problems, and then really, with better understanding, to develop or propose more effective countermeasures of what we can do in space and even after space flight to counteract that. So the mission that I'm part of is Rodent Research 9. We're looking at two different biomedical issues. The first is visual impairment that occurs in some of the astronauts. To date, it only occurs in male astronauts. And so we're looking at a couple of different aspects of how visual impairment may occur. And the first thing we're looking at is the vasculature and the pressure in the eye. And if I can have the first slide, please. You can see in the eye that there's a pretty dense vascular network. And this vascular network controls something called the blood-retinal barrier. Now, many of you have heard of the blood-brain barrier, which is a very tight control of fluids and proteins and other molecules that cross into the eye or into the brain. And so this is the picture of the blood-retinal barrier. We'll also be looking at the blood-brain barrier in the brain and looking at different ways that